is file, example data set, up to the manual data set, and then check for the time series, and then check for the past current too. So as long as you're having internet, your interface will be displayed. Your internet will be nothing. You're going to be displayed. Can we describe our data set? This is our description. Description of your data set, please. Can we run a summary? Summary. Summary. Can we run a summary? So after running the summary, can we just look at maybe so we are going to start with rebrace our open economy. Last time we you know that from macro economy. What is the component of my open economy? The income, the GDP. GDP is equal to C plus I plus G plus NX. We assume that government expenditure is coming from taxes. It's coming from taxes. So what the government is spending is what we assume that's what the government is spending is what it correct from citizens. Despite the external financing like from dates and even also grants. So that there is an open economy. And then for a closed economy, GDP is equal to C plus I plus G. So we're going to run the model number one as a closed economy. And then the model number two will be the government plus consumption plus investment. The figure economy, right? The economy which doesn't involve the government. There is no government intervention. We remember the classical economy, what they say. Classical economy, they assume that the demand and supply can be driven by invisible hand, right? So no government intervention. So we assume that maybe the economy is being driven by the consumption and investment, but there is no government spending, no government intervening. So it will be our model two. Okay, let us taste. Okay, before tasting, before tasting, okay. So our regress in theta, it will be regress y, c, I, and G for the first model in theta, right? The first model. The second model, it will be regress y, c, I. So the difference will be to remove the government expenditure to see whether the model will be just the y will be explained because we are thinking that we are suffering what we call irrelevant. So we have had many models we need to remove. So that is the issue that we are meeting with it. Okay, let us run. Our first model is y, c, I, and G. What can you realize for the first model? The first model is I, C, okay, income, consumption, investment, and government expenditure. What can you realize on the R square? What can we realize on the R square for the guys who are on the back? Hello? What can you realize on the R square? Yes, please. The R square is equal to 1. Yes. The fact that the R square is equal to 1, yes, your colleague is saying well. As long as the R square is 1, it implies to have 100%, which means we are having an overfitting. Is it better or not? Who agree that to have overfitting model is better? No, it's very bad. It's very bad. Yeah. Oh. Why? It can't help us to predict our y hat. Yeah. Are we on the same page? Can we write this equation? Is it possible to write this equation? I want to delete. Okay, can we try to write this equation? Okay, we're going to say y, my y will be equal to, what is my intercept? What is my intercept? Negative 4.15 times 10 minus 7. Very good. Plus my consumption plus my investment plus my government expenditure. So the slope is equal to 1 plus the error term. That will be my result. Okay, let us run the second equation because what issues are we suffering here despite the overfitting? We are suffering from irrelevant variables. Irrelevant variables. So which means that we need to deduct our irrelevant variables. That's why we choose to remove government expenditure and remain with consumption. Okay, let us run the second model. It's equal to replace y space c and I. Any changes? Any changes? Yeah. No, no G. So yes, I have removed G. Yes, I have removed G. Perfect. So there is any changes? Obviously, obviously, we put the second model here, right? What can you realize? Who can let me know the R square? Yes. So the R square is equal to 0.97, equal to 97%. Still high, but at least there is a reduction. Can we write our equation to be y equal to -8, the inception, plus 1.2 c plus 0.8 I. Oh, the car is not here. So my equation will be y equal to -8, it's 93 plus 1.2 c plus 0.8 I plus the error term. So which means my income, the level of income that the model is having is the contributions of two variables. Whereas the first model, we had the contributions of three variables, including the government spending. Are we on the same page? Who can interpret the C, the consumption? Who can interpret the consumption? So let me assume the consumption is done in for 1 USD, and the income also it's 1 USD. I'll be saying, because we haven't transformed our variables are still units, are still in currencies. We'll be saying one US dollar increase or change in my consumption in in in, in personal consumption. So is it a personal consumption? Let us check. Well, or it's an international consumption. Okay, consumption in individual, so it should be a personal consumption. An increase or a change, $1 change in personal consumption will will decrease or will increase? Will decrease or will increase? Will decrease. D. Increase will increase. Thanks, colleagues. $1. Yes. Yes, because it is positive. So the reason why we say it's increased because of the sign. The sign is positive. So we increase. Let us see the status of Y. So the consumption, no, okay, the income is time for why is it, okay, it's an aggregate income. Yeah, it's an aggregate income, which is correct, which is the GDP. So the other name of the other name of GDP, it's an aggregate income. Income slash aggregate. Okay, slash demand. So we increase the income. How much? 1.2 USD. What if I start with 100 USD? What if I'm changing to start with 100 USD? 100 USD, because I have make a times 100, will increase my consumption by the slope times 100, 120 USD. And then we are going to add other factors to increase my income, 1.2 USD. Other factors remain constant. Other factors remain constant. Why are we saying other factors remain constant? We assume our error term is a white noise. We assume our error term is a white A white noise should be a white noise. So what is the characteristic of being of having an error term with a white noise? The characteristic of having an error term which is white noise, please. Our error term should be having a constant mean. The variance should be equal to sigma, right? Okay. Is it statistically significant? Yes, it is, and it is statistically significant due to that the p-value is less than less than 10%, less than 1%, 5%, yes, less than 5%, 5%. Can we repeat for the investment? Can we repeat for the investment? Anyone who can just repeat for the investment. Yes, 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 please. You can use the same formula and say one USD increase in investment or change in investment we increase because it's a positive the investment by the income by 0.8. Other factors remain constant and that it is statistically significant even for the p-value is less than 5%. My handwriting is very worse. I should be able to study autography. Autography. I haven't studied branch school. This is. Do you want me to? Okay, let me see whether I can just maximize it with only my black one, not changing to white because white is not making things wrong, changing things to become worse. Then you have many difficulties. Because my orthography is very worse. I'll, I'll be using the black for you to see. You haven't yet finished. So can you run the first model again? So the only way to run the first model again, you just in your history, please select your history and then select the first command that you've run, right? So you go for the first your history as long as you can double click on it, your codes will be returned here, right? If I just click maybe for the yesterday codes, the code will automatically comes again, right? That's how you can recall your codes from the history. Any question? Oh, so you need to come here. This is my first model. How can I save it? I have shared the video. How can I save the first model? Estimate, estimate, store, store, model one. Why model one? Why model one? It's the name of our first model. If it's model 5, I will just put model 5, right? It's because it's our name. We can just make even write estimate store Raymond. So our model will be called my name, right? Or your name. You can say estimate store Stephen. So the model will be called Stephen, right? So it doesn't doesn't mean you need to put model 1 always. No, it's because of a naming. If I change to model 3, model 4, feel free to understand the behind the scene. The official name, the better name. Okay. Okay. So let us use. Can you see any impact? Can you see any impact in your variable window? In your variable window? Please look to my pointer. So as long as you have just store your model, automatically is kept within your data set. Can we browse and see the model 1 where it is kept? We can browse, see where our model 1 is kept. For model 1, our model 1 is kept here on the last column. It is being added to our data set. Are we on the same page? Oh. Can we learn model 2? This is my model 2, the figure economy. Any question? And then we estimate store model 2 and then enter. Can you check for model 2 where it has been okay, it has been stored. You can come and then check for the variable window. Yes, please. Okay, can we browse both? Let us browse model 1. So we need to come and then say browse and then do the two sides and then enter. I will be having two models. I'll have only the table for two models. Do you see any difference between model 1 and model 2? No, there is no difference. It means my probability is that we are going to maintain model 1. The probability is that we are going to maintain model 1. If there is no change. Okay, let us run L test. We are going to run. We are going to run the model comparison. For which purpose? To select the best one, yeah? For the purpose of selecting the best variant. Okay, the best model, right? Because we are thinking the first model is adding more irrelevant variables, and then we have omit one variable, and then we want to see whether the impact is okay. Remember, I have used the star. That's why this will not be a command. Please, if you don't use the star, you have a red comment. So because I have used the star, it is coming as a comment. If you don't use a star, it will be considered as a command. But if you use a star, it will be considered as a comment. So if I put double slash and then Raymond, Raymond is the teaching statement, right? You can see double slash is not effective. Let me see one slash. not working, so we need to use a star. If you want to put a comment, you use that, right? Okay, star is working within the commands. Star is the only one which is working, but in the do file you can have multiple way. You can use the slash in the do file, but in the commands you need to use a star. Okay, so we are going to use L. Who can recall me the code that we used yesterday, last night? So to make comparison, was L fit? L fit? Okay, L, okay, double L, the long one, and even the small one, test, L fit. And then this there is R. L test. Okay, now I'm just making it better for you to see. Now it's at the maximum. L tests model 1 versus model 2. Hello, the name. You use only the name because my model 1 is being stored as model 1. Yes, please. Okay, do you want me to return the code? The comments. Remember this teaching statement. But you need to put a star, right? To make it performant. But if you use a slash, it will give you an error, a red one. Like this one is giving me a valid name. So in do file slash is acceptable, but for the commands the only acceptable is the star. It's not, yes, it's not also working. It's not working. It's working. Okay, maybe the way I did it for, but you use the star. Before you use the star. Okay, can you remove the star? If you remove the star, it will not working. It will not working. So the conclusion is that the star is helping us to make a comment within our view result. Okay. Can we interpret? Can we interpret? Let me just screenshot for you. Let me just screenshot for you. It's the likelihood ratio. So the arrow, okay, oh, better to explain stepwise. So your colleague is asking, so the L, yes, please. Hmm? You still? It's not working. Sure. Oh. Let me come to you.